Today I want to correct your homework. Given the function f of x equals 2 then x over x2 minus 1 over x2 plus 1. The domain of definition of this function is 0 plus infinity. First question is determine the limit of f of x when x approaches to 0. By simply replacing ln of 0, we know that it's equal to minus infinity. Minus infinity divided by 0 equals minus infinity. Minus 1 over 0 equals also minus infinity plus 1. So it's minus infinity plus 1. It's minus infinity. Okay? Limit when x approaches to plus infinity of f of x is equal to plus infinity over plus infinity. It's an indeterminate form. To eliminate this indeterminate form, we have to use the Hopital rule. The Hopital rule, I mean, we have to replace the numerator by its derivative. The derivative of ln x is equal to 1 over x. The derivative of x2 is equals to 2x. So the function will be limit when x approaches to plus infinity 2 times 1 over x divided by 2x minus 1 over x2. By simple replacing, we obtain 1. So y equals 1 represents a horizontal asymptote of the curve t. The question number 3 is calculate f prime of x and show that it's equal to 4 into minus 1 minus ln x divided by x cubed. The function f of x is in the form, first part is in the form of u over v, and we know that u over v prime is equal to u prime v minus v prime u divided by v squared. This quantity is in the form of u over v, also it's equal to u prime v minus v prime u divided by v squared, and the derivative of this term is equal to 0. After calculation, we obtain 4 into 1 minus ln x divided by x cubed. To set up the table of variation of this function, we have to study the sign of the derivative. We remark that in the denominator we have the expression x cubed, and x belongs to 0 plus infinity, so x cubed is positive. The question is, what is the sign of 1 minus ln x? So we suppose that this term is bigger than 0, and we solve this inequality. We obtain minus ln x bigger than minus 1. The unknown, I mean the expression containing the unknown x, is on the left and the number on the right. So from this step to this step we have to multiply by negative sign, then the order change. We obtain ln x smaller than 1, and we apply e exponent ln x smaller than e exponent 1, so we obtain x smaller than e. Remark that when x is smaller than e, the expression 1 minus ln x is positive. So we can draw the table of variations of this function x f prime of x f of x. In this table we have the domain of definition 0 plus infinity, and we have to write the root, the number e, approximate equal 2.7. Before e, the derivative is positive, and after e, it's negative. Then the function is increasing when x belongs to 0e, and it's decreasing when x belongs to e2 plus infinity. Using your calculator, you can find the value of f of 1. F of 1 is equal to 0, and now we can draw the graph of this function to study the sign of f of x according to the values of x. in an orthonormal system of axes, x prime or x, y prime or y, we have a horizontal asymptote y equals 1. So first step is to draw the horizontal asymptote. In general case, first step is to draw the asymptotes. Y equals 1, and to draw this function we have the points. We read in vertical side 0 minus infinity. This is the point 0 minus infinity. Second point is 2.7, 1.6, and this point represents the maximum of this curve. And finally we have the point plus infinity 1. If we plot these 3 points, and knowing that the curve is increasing than it's decreasing, I mean this curve admits a maximum, we can draw the curve of this function. By simple reading the graph or the curve of the function and comparing this curve or the relative position of this curve in blue with respect to the horizontal axis x prime x, we can study the sign of the function f of x. We remark that when x belongs to 0, 1, the curve in blue is below the x-axis, so the function is negative. And when x is bigger than 1 in this region, the curve in blue is above the x-axis, so f of x is positive in this region. 5a, by using an integration by parts, calculate the integral from 1 to e of ln x over x2. We write this function in the form of product 1 over x2 times ln x dx, the integration of 1 over x2 times ln x dx. Let u equals ln x, so its derivative equals to 1 over x. V prime equals 1 over x2, it's in the form of x exponent minus 2. Then v equals x power minus 1 divided by minus 1 equals to minus 1 over x. And we know that the integration of u times v prime equals to u times v minus the integration of u prime times v. So I equals the product of these two expressions minus the integration of the product of these two one. Okay, so by simple calculation and by using my calculator, we obtain the value 0.26. 5b, calculate or deduce the area of the region bounded by the curve T, the axis of the abscissa, and the two straight lines of equation x equals 1 and x equals e. Using the curve of this function, we have to determine the region, the demanded region. Okay? Between x equals 1 and x equals e, and the region is bounded by the curve C and the horizontal axis x prime x, so the demanded region is the region in green, this one. And we remark that this one is above the x-axis, so the area of the demanded region is the integration from 1 to e of f of x dx, not minus f. Okay, since the curve in this part is above the x-axis. area equals the integration from 1 to e of the function f of x dx. And we know that the function f of x is in the form of 2 ln x over x2 minus 1 over x2 plus 1. Using the preceding part, we know that the value of integration from 1 to e of ln x over x squared, it's equal to 0.26. Then the area is equal to 2 times I minus the integration of this quantity from 1 to e plus the integration of this quantity from 1 to e. Okay? Using my calculator, we obtain the value 1.606 u squared, and it's the value of the area of the region bounded by the curve and the axis of abscissa and the two straight lines x equals 1 and x equals e. Now in part B, given the function g of x defined by x minus 1 over x minus 2 ln x divided by x over 0 plus infinity. First question, calculate limit when x approaches to 0 and determine or deduce an asymptote to the curve C of the function g. Limit when x approaches to 0, it's a simple replacing of 0 in the function g of x. So we obtain ln of 0 divided by 0. We know that ln of 0 is minus infinity, and we have before ln 0 minus 2 minus infinity, it's a plus infinity. When x approaches to 0, we obtain plus infinity. Then x equals 0 represents a vertical asymptote. Part 2a, calculate or determine limit when x approaches to plus infinity. We replace x by plus infinity, so it's plus infinity minus 1 over plus infinity. 1 over plus infinity, it's 0. And ln x over x, we obtain infinity over infinity, so we apply Hopital rule. Then limit when x approaches to plus infinity of this quantity is equal to 0. So the limit of g of x equals to plus infinity plus 0. It's equal to plus infinity. Part B, prove that the straight line D of equation y equals x is an asymptote to C. To prove that the line D is an asymptote, we have to calculate the difference between g of x and the straight line D. Then we find the limit of this quantity when x approaches to plus infinity. G of x minus x, it's equal to minus 1 over x minus 2 ln x divided by x. Its limit when x approaches to plus infinity equals to 0. Then the straight line D of equation y equals x represents an oblique asymptote to C. Study the relative position of C and D in part C. Study the relative position between the curve C and the straight line D. Also calculate g of x minus x, and we study the sign of this quantity. G of x minus x, it's equal to this fraction minus in common 1 plus 2 ln x divided by x. The sign of x is positive since the domain of definition of the function g is 0 to plus infinity. Okay? Our problem is to find or to study the sign of this quantity, minus 1 plus 2 ln x. So we suppose that this quantity is bigger than 0, and we solve this inequality. Now we multiply by negative sign, so 1 plus 2 ln x will be smaller than 0, and we solve this inequality. We obtain x is smaller than e power minus half. We read this result from. من الآخر للأول. أوكي شباب؟ طيب. And we draw a table of sign. When x is smaller than e power minus half, this quantity is positive. So in this region we have plus, and after e power minus half it's minus. In this region c is above d, and in this region c is below d. هيدي البوينت اللي عم بحكي عنها هلا كتير مهمة. بالشهادة في علامات كتير على هيدي النقطة. نحن عرفنا ايمتى الكيرف above the line, and for what values of x the curve is below the straight line, maybe they have point of intersection. This number x equals e power minus half is accepted in the domain. I mean e power minus half, إذا نعمل لها calculation using my calculator, we obtain a positive number. So this number belongs to 0 plus infinity. For x equals e power minus half, the curve and the straight line intersect. They have a common point. How can we find the coordinates of this common point? The abscissa of this point equals to e power minus half. We replace this abscissa in the equation of the line d or in the equation of the function. I think it's so easy. If we replace it in the equation of the line is y equals x. Okay? Then the point of intersection between the straight line d and the curve c is e power minus half, e power minus half. Question number 3 is calculate g prime of x and set up the table of variation of the function g. We want to calculate the derivative of this function. The derivative of x is 1. Derivative of 1 over x in the form of u over v, or it's a rule. So it's directly equal to minus 1 over x2. Also, ln x over x, it's in the form of u over v, u prime v minus v prime u over v squared. After simple calculation, we obtain g prime of x equals to f of x. So g prime of x equals f of x. And we know that the sign of f of x. This idea is very important. These two quantities are equal, so they have same sign. Not same table, same sign. And we know that using the preceding part that the sign of f of x is positive after 1, and between 0 and 1 it's negative. So to draw the table of variation of the function g, x, g prime of x, g of x, we write the domain of definition of the function g and the number such that the derivative change its sign. So the number 1, since f of x, if x smaller than 1 it's negative, if x bigger than 1 it's positive. So x 0, 1 plus infinity. After 1, g prime of x is positive since f of x is also positive, and g prime of x before 1 is negative, so the function is decreasing than increasing. G of 1, by simple replacing in this equation x by 1, we obtain 0. Now in part 3b, trace the curve C. In the table of variation, we have the function is decreasing than decreasing. It admits a minimum for abscissa 1 ordinate 0. To draw this curve, we have to draw first of all the asymptote. The asymptote is the straight line of equation y equals x, represents an oblique asymptote, and the vertical asymptote, the axis y prime y. First point is 0 plus infinity. We look in vertical. Second point is the minimum, is the point of abscissa 1 ordinate 0, and the last point is plus infinity, and we have a common point between the straight line y equals x and the curve C. It's the point of coordinates e power minus half, e power minus half. E power minus half, using my calculator, it's approximate equal to 0.6. So the points are 0 plus infinity, 0.6, 0.6, and 1, 0 plus infinity plus infinity. First point is 0 plus infinity. Second point is 0.6, 0.6. This point belongs to the straight line y equals x. And the minimum is 1, 0. So we draw a minimum. Okay? And plus infinity plus infinity. The curve is decreasing using my table of variation. Then it's increasing to arrive to the oblique asymptote. The question number 4. Let us be the area of the domain bounded by the curve C, the straight line D, and the lines of equation x equals 1 and x equals e. Prove that s is smaller than e squared minus 1 divided by 2 unit square. Between x equals 1, this is x equals 1, and x equals e approximate 2.7. So this is the region between the straight line D and the curve. Region limited between curve and line, so we find the integration of the curve above minus the curve below. So s equals the integral from 1 to e y of d minus g of x. Using my calculator, I can obtain the value of this area, and we compare this value with the given value e squared minus 1 divided by 2. So it's easy to say that it's smaller than e squared minus 1 divided by 2. Part 5a. Show that g admits an inverse function when x bigger than or equal to 1. We remark that when x bigger than or equal to 1, the function is continuous and strictly increasing over 5b. Over 1 plus infinity, g is continuous and increasing, so g admits an inverse function. Inverse function g minus 1. Okay? Determine the domain of definition of g minus 1 and draw the curve, its curve in the previous system. Part 5b. Domain of definition of g minus 1 is the image of this domain. So the image of 1 is 0, the image of plus infinity is plus infinity. So domain of definition of g minus 1 is equals to 0 closed plus infinity open. Okay? To draw the curve of the function g minus 1, first of all, the two curves CF or CG, and CG minus 1 are symmetric with respect to the straight line y equals x. The two curves C and C prime, the curves C and C prime are symmetric with respect to y equals x. So, what's the meaning of symmetric with respect to y equals x, if we have a point belongs to the curve C of abscissa 2 ordinate 5, so the corresponding point belonging to the curve of the function of the inverse function is 5, 2. The abscissa and the ordinate change their places. Okay? The points belonging to the curve C are 0 plus infinity, 0.6, 0.6, 1, 0, plus infinity, plus infinity. We have to remark that the question is prove that when x bigger than 1. Yani the accepted point are the points having an abscissa bigger than 1. So this point having an abscissa this bigger than 1 and plus infinity is accepted. On the curve C, we have the point 1, 0. So the corresponding point on C prime is 0, 1. Okay? The second point is plus infinity. The corresponding point is plus infinity. I repeat. The 2 points 0 plus infinity, 0.6, 0.6 are not accepted since the question is prove that when x bigger than 1, the function g admits an inverse function. Okay? So we have to draw 2 points. The 2 points are 0, 1, abscissa 0, ordinate 1. And plus infinity, and we remark that the function g is increasing, so g minus 1 is also increasing. plus infinity يعني بدها توصل لهون، فهي بهالشكل. هيدي هي الكيرف، نظبطها شوي صغيرة معلش عشان تكون قريبة من هون. اوكي، هيدي هي الفانكشن. اوكي، هيدي السي برايم. Last question is, does the equation g of x equals g minus 1 of x admit solution? Justify your answer. What's the meaning of the point of intersection between the curve CF and the curve CF minus 1? The point of intersection between CF and CF minus 1 or CG and CG minus 1 are the solution of the equation g of x equal g minus 1. If the curve of a function and the curve of its inverse intersect, so they intersect at the straight line of equation y equal x. Since these two curves are symmetric with respect to this straight line y equals x, if we have a point of abscissa 2, 5 on the curve of the function, so the corresponding point belonging to the inverse is 5, 2. يعني إذا بيكون عندهم intersection بيكون الأبسسة والordinate are same. Okay? يعني نحن to find g of x equals g minus 1 of x, we have many methods to find the solution of this part. We remark that the curve C prime and the curve C, يعني curve in green and curve in blue, they don't intersect. So the equation g of x equals g minus 1 of x don't intersect or don't have any solution. بيجي واحد بيقول لي من الشباب لا يا استاذ ليك هي عامله point of intersection هون. انتبهوا please. عم نقول for x bigger than 1. I know that if we use the curve, this curve and the green one intersect at this point. but this point having an abscissa smaller than 1 يعني it's rejected. فإذا بنقول the curve C and the curve C prime don't intersect, so the equation g of x equal g minus 1 of x has no solution. اوكي هيك نكون خلصنا احنا الاكسرسايز كبير وماكن، ان شاء الله تكونوا استفدتوا. يعطيكم العافيه يا رب.